physics project. Ben, Bruce, and Elisa. We have the amazing Spider-Man GIF, as I like to call it. In this GIF, we have one man that is able to walk up the side of a building, and while holding onto a rather long pole with 2 or 3 other people pushing him forward. And the way this works is basically through physics. Different friction forces, gravitational force, normal force, and also the force that is applied by both parties here. Now here we see kind of a make-up diagram of what's going on here. We have the clone trooper in the front being pushed by the 2 drones. In the back, we see that there's only going to be a straight horizontal movement going on in this beginning part of the whole system, because this is really a system of forces working together over time. Now here we have a free body diagram representing this. Now again, like I said, it is a complete horizontal movement. There's very little friction based on the fact that these 2 men are trying to run this pole and the other person forward. There's a little bit of resistance, but for the most part, the applied force is very, very strong. That's why it is a larger arrow, as we see, showing more newtons. Now we see change in the GIF, just a little freeze frame as the clone trooper is halfway up the building. We notice that after this there will be a change in the free body diagram in the way that the forces are working. We can also see this through calculus. We're not going to do the calculations exactly, but if you wanted to, we would take calculus because we see a rate of change over time as the clone trooper runs faster and faster up the wall. Now here's a free body diagram explaining that. We do not know the angle. Of course, it depends on the time of when everything is taking place, but we do know that over time, as the clone trooper gets closer and closer to the top of the building, we do see a increase in the angle, more applied force going upward because of the pole that the 2 other drones are pushing, but everything else is the same, normal force and gravity alike. Now we see a different perspective, again demonstrating that the clone trooper has now made it to the top of the building, but we still see a rate of change again, as said before. Now one of the things about this is, of course, perspective. Why is the clone trooper able to stay up there? Well, it's because you have to think about the way that the forces are moving with each other. See, and in this free body diagram, you see that normal force and friction actually change because of the perspective of the clone trooper. Friction is what stops him from sliding down, and the applied force is actually what keeps him slightly up, because it is pressing against the building, but because it's on an angle, it's also going upwards, adding to that friction force. Also, normal force has changed as well. Now let's see that in a different perspective. Here we see a different perspective. The image was rotated so that we can clearly explain it a little bit more. Imagine to the left, gravity is acting on the clone trooper. To the right, friction and the x value of the applied force. Normal force is acting upwards above him, and a little bit of the y of the applied force is acting downwards, keeping him as if he was on the ground, acting towards the building. Here we see the free body diagram that explains that a little bit more clear. We see normal force is acting as it usually does. Gravity is acting all the way to the left. Friction is a little bit less than gravity, but the thing that really keeps the clone trooper from moving, falling, or going higher is the x of the applied force that really balances everything out, and also the y of the applied force, keeping him closer to the building. Again, thank you very much, and have a good day.